Hey Calculus. Alright, I just wanted to make a quick video first for a couple reasons. So you can check your answers to 1 through 20 here. So you can pause the video and check those answers. And then also to go through a few of these algebraic limit evaluations. So hopefully you copy down those notes. And so when we do problems like 21 through 26, the first thing what we're going to do is try to plug in the value. So anytime you get a limit, your first thing you always try is direct substitution. So 21, I get limit as x approaches 9 of x. So I plug in 9, I get 9 as my answer. Then for 22, plug in negative 30, I get negative 30 as my answer. For 23, there's nowhere to plug into, so it's just limit of a constant, which is just that constant. So the answer for 23 is just 5, and 24 is the same way. That limit is just going to be 6 because it's the limit of a constant. Okay. Now when I get to a problem like 25, the plugging in is a little bit more involved. So I will go with 12 times 1 to the third plus 1 squared minus 1, which equals 12 plus 1 minus 1, which equals 12. So my answer there is 12, right? When we do direct substitution, if we get a nice answer, that's my answer. Number 26, 3 times negative 5 minus 1 would be 3 times negative 6, which is negative 18. All right, let's try a few more examples down here. In number 27, we have limit as x approaches 5, so I'm going to plug 5 in. I get equals 5 plus 1 over 5 plus 2. That would be 6 over 7. So there's my answer. And finally, in 28, let's see what happens. Equals 3 squared minus 5 times 3 plus 6 over 3 minus 3. Uh-oh, that's 0 on the bottom. I've run into a problem. Let's see what I get on the top. 9 minus 15 plus 6. That is 0, isn't it? 0 over 0. Okay, as you hopefully saw in the notes, we call this indeterminate. Okay, and when we get indeterminate, what it usually means is there's some simplifying we can do. So I'm going to try to factor this. So now I have to go back to the beginning, and I call it equals limit as x approaches 3, and I'm going to factor x over x minus 3. I'm going to guess there's a minus 3 involved. X minus 3 and x minus 2 would work. And I like that because that cancels with that. And so I get the limit as x approaches 3. As x approaches 3 of x minus 2. And now I can go to direct substitution. Plug in 3 minus 2, which is 1. And so my answer to this problem ends up being 1. Okay, so notice this 3 steps here. First we tried it out and got indeterminate. Then we factored and canceled. And then finally we tried it out one more time. Okay. On the back we have a few more complicated problems. So let's try a couple of those. All right, on this page in 29 and 30, I'll let you guys try those on your own. But let's try 31. So for 31 here, what I'm going to do again is start with direct substitution. So when I do that, I'm going to get equals 0 minus 6 squared minus 36 over 0, which is 0 over 0. If you get 36 minus 36, that's 0 over 0. Okay, so here again, it's indeterminate. You don't have to write that every time. I'm just doing it so you remember, or so we could get used to that word, indeterminate. Okay, And so that tells me, okay, I should try to simplify this. I should maybe see if I can factor or, something algebraically to simplify it. So in this case, I'm thinking I should expand the top because that's something I can do here. So limit as x approaches 0 of x minus 6 squared is x squared minus 12x plus 36 because it's x minus 6 times x minus 6. And then this is minus 36 from that original numerator, and then over x in the bottom. Okay, that's going to simplify on top to the limit as x approaches 0 of the 36's cancel, so it's x squared minus 12x over x, and I can factor an x out of the top. So now I get limit of, as x approaches 0, of x times x minus 12 over x, and those x's cancel, leaving me with the limit as x approaches 0 of x minus 12, and now I can do direct substitution. 0 minus 12 equals negative 12. So my answer here is negative 12. All right, and lastly for this video, I would like to look at the very bottom problem, number 36. So in this problem, what we'll do is we will use those limit properties that were on the very first slide of the notes that you took. So here I'm told a couple of facts about limits. I'm told that f of x as x approaches 4 has a limit of 2, and then g of x as x approaches 4 has a limit of negative 5. And then I want to find this limit as x approaches 4 of 3 times f of x minus 2 g of x. Okay, and so using our limit properties, we can kind of break this all up. So first we have a constant on the outside multiplied by it, or a coefficient, another way would be to say that. And one of the properties is we can multiply that coefficient in front of the limit. So this is going to turn into equals 3 times the limit of f of x minus 2 g of x as x approaches 4. Okay, and then I can split up a subtraction. So that's going to be 3 times, now I need to use parentheses here because I'm multiplying that 3 times this whole result. The limit as x approaches 4 of f of x minus, and I'll use that coefficient property again, 2 times the limit as x approaches 4 of g of x. Okay, and now what I've done is I've created something where I know the answer to these things. So that red box, I know the answer is 2, and the blue box, I know the answer is negative 5. So I can replace that, so this is going to be 3 times red box, so 2, minus 2 times blue box, negative 5, which is 3 times 2 plus 10, 3 times 12 is 36. And so my answer there is 36. So there is a problem in the book homework that's similar to this one. Okay, hopefully this was helpful. Thanks for watching.